Hello guys, good afternoon. You are welcome to my YouTube channel, the Explicit Tutorials. As you all know, I'm Tutor Joseph or Mr. Explicit. As you watch this video, endeavor to subscribe so that when I upload new content, you would be notified by YouTube, alright? So without wasting much of our time this morning, we will be discussing Chem 101, a topic called matter. Alright, this topic is very easy, but when you ask certain group of science students what is the meaning of the word matter, I've had a student before, are you a matter? He said, no, God forbid, I'm not a matter. If you are not a matter, it means that you don't have mass, and of course you don't occupy space. That is what it means. But when you ask some students what is matter, you hear four definitions, but it is good you stick to the one that best explains what matter is. The first one, matter is anything that has weight and occupies space. And matter is anything that has mass and occupies space. Matter is anything that has molecule and occupies space. And matter is anything that has atom and occupies space. So which of the four definitions or which of the four options best explains what matter is? The second one explains it better. Matter is anything that has mass and occupies space. There's some textbooks, even BUK chemistry textbook on material will tell that matter is anything that has weight and occupies space. It is wrong. Avoid saying it. The most accepted definition of what matter is that matter is anything that has mass and occupies what? Space. Now, what is the meaning of mass? Mass means the quantity of matter that the body contains, and it is measured using an instrument called the beam balance. Weight is simply the force that pulls an object towards the earth. It is a vector quantity, but mass is a scalar quantity, and weight is measured using an instrument called the spring balance. That is how it is. So matter is anything that has mass and occupies space. All living things, all non-living things are matter because they have mass and occupy what? Space. I believe that is taken. Now we have two classes of matter. Matter is divided into two parts. One, we have the ones that are pure substances. Pure substances. Alright. We also have the other one which is called mixture. Alright, mixture. Now, under the pure substances are divided into two. They are compounds and what? Elements. Compounds and elements are all pure substances. Alright? Then mixture, you now have two types: homogeneous mixture, also called solution. You now also have the other one, which is heterogeneous mixture, which can also be called a suspension. All right. So this chart explains everything about matter except the state of matter: the solid, the liquid, and the gaseous state. Before we jump into explaining these four terms on the board, permit me to introduce what we call atom, molecule, and what? Atomicity. And let me also bring in Proticity. Yes, trust me, you know this word. Alright, another word for Proticity is basicity. Alright, basicity, that is the proticity or the basicity of an acid. Now, the first word here is atom. What is atom? Atom is the smallest part or the smallest particle of an element that takes part in every chemical reaction and remains chemically unchanged at the end of the reaction. I take it again. The atom is the smallest particle of an element that takes charge in every chemical that takes part in every chemical reaction and remains chemically unchanged at the end of that reaction. That is what an atom is, and it is universally accepted as that. The molecule means the smallest part of a substance that exists alone and still retains its chemical properties. They also take part in a chemical reaction. A molecule is the smallest particle of a substance that exists alone and retains its chemical properties. It also takes part in a chemical reaction. Take note of that. Then atomicity means the number of atoms present in a molecule. Atomicity means the number of atoms present in a molecule. Some elements are diatomic, some are monoatomic, some are diatomic, some are polyatomic. It depends. The word mono means one. So when we say monoatomic elements are elements that have just one atom in their molecule. All group 1, group 2, and transition metals are monoatomic because they have one atom in their molecule. Group 1 element, group 2, and the D block element, which we also call transition metals. They are all monoatomic. But hydrogen, which is diatomic, does not belong to any of the group in the periodic table. So if you are asked what group does hydrogen belong, you say it does not belong to any of the group in the periodic table. It can exist as a metal, it can exist as what? A non-metal. But oxygen is also diatomic, alright, because it has 2 atoms in its molecule. We also have some elements that are triatomic. Now these elements, they have 3 atoms in their molecule. Example is what? Ozone. The ozone. Alright? The ozone, which is O3. But oxygen is what? Oxygen is what? O2. So ozone is triatomic because it has 3 molecules of atom. That is 2 oxygen. 1 oxygen, 2 oxygen, 3 oxygen. That makes it triatomic element, alright? Diatomic 2. We also have some that are polyatomic. That is, they have more than 3 atoms in their molecule. Take for example phosphorus. Phosphorus has 4 atoms. That is, you say it is tetraatomic. You also have sulfur that has 8 atoms. We say it is octaatomic. So phosphorus and sulfur are called polyatomic elements because they have more than 3 atoms in their molecules. I believe that is taken. We also have atomicity, proticity or basicity. Now this word means the number of replaceable hydrogen ion present in an acid. Alright? H2SO4 is diatomic. H2SO4 is what? Diatomic. HCl, HNO3 are monoatomic. What about CH3COOH, which is called ethanoic acid, trivially called acetic acid? It is monoatomic. What about ether 1,2-dioic acid, which is also called glycol? Ether 1,2-dioic acid, which is a dicarboxylic acid, it is dibasic. That is, it has 2 hydrogen. It has 2 replaceable hydrogen ion in its molecule. They are all acids. Alright, so it is diatomic, HCl, HNO3, monoatomic, CH3COOH, monoatomic, H2SO4, diatomic. I believe that is taken right. So let's continue. So we have explained these 4 terms. Alright, so let's look at what compounds and elements are. And of course, compounds and elements are not new to us as science students. Alright, they are not new at all. All of these terms are not new. Alright, if you can understand this, if you can understand what these terms are all about in the world of science, then you are good to go. What are compounds? Compounds are substances, alright, that are made up of 2 or more elements that are bonded together chemically. Compounds are substances that are made up of two or more elements that are chemically bonded or joined together. And because they are chemically bonded together or joined together, it therefore connotes or denotes that they can only be separated through chemical method. So the method that is used to separate compounds is called chemical method. I take it again. Compounds are substances that are made up of two or more elements that are chemically bonded or joined together, and they can only be separated via chemical what? Method. Take note of that. In the world of science, we have hundreds of thousands of compounds, numerous examples of compounds. Water is a compound, H2O. That is H2O, right? H2O is a compound. Why is it a compound? Because it has two elements. What are the elements? Hydrogen and what? Oxygen. What about ammonia? HNO3. It has nitrogen and what? Hydrogen. What about sulfuric acid, which we commonly call tetra, also sulfuric 6 acid, H2SO4. What are the elements? Hydrogen, sulfur, and what? Oxygen. Three elements. What about calcium carbonate, which we commonly call limestone? Alright, that is calcium, carbon, oxygen. What about baking soda, which is NaHCO3? Alright, it has sodium, it has hydrogen, it has carbon, it has what? Oxygen. So these they are substances that comprise two or more elements that are chemically bonded or joined together. It therefore means that they can only be separated via chemical what? Means. I believe that has been taken. We now have elements. Elements are substances or they are entities which cannot be divided or split into smaller entities by any chemical method. Elements are substances or entities that cannot be split or divided into smaller parts or into smaller forms by any chemical method. They cannot be split, they cannot be divided, they cannot be, that is, you cannot break them down by any chemical means. Take note of that. That is taken. And of course, in the periodic table, we have 8 metalloids, 7 nonmetals, and we have 8 metalloids, 7 nonmetals, and 6 noble gases. Others are metals. So take note of that. That will be a discussion. When I'm taking periodic table, I'm going to be explaining the properties of each of the elements in the periodic table, or all the groups are based on their chemical terms. Okay, so we have explained compounds, elements, and all these terms. So the next part is homogeneous mixture and heterogeneous mixture. Now, when you hear the word homogeneous mixture, the word homo means one or the same entity. All right, homogeneous mixture. Which we also call solution. Alright, a homogeneous mixture is a mixture whose components or constituents are uniform or definite. Homogeneous mixture is a mixture whose components or constituents are definite. They are definite or what? Uniform. If they are definite or uniform, it therefore means that the components that make up this mixture cannot be differentiated or distinguished. Alright, that is, you cannot differentiate them at all. Alright, you cannot differentiate them because they are definite or they are uniform. What are examples of homogeneous mixture? Examples are ink. Ink is a good example of a homogeneous mixture. You cannot see the constituents that make up ink. Ink is a good example of what homogeneous mixture. Okay. Apart from that, we also have alloys. Alloys. What are examples of alloys? We have the bronze. Bronze is made up of copper and what? Tin. Copper and tin. What about brass? Brass is made up of copper and what? Zinc. So all of these, all of these are examples of what? Homogeneous what? Mixture. Take note of that. We now also have heterogeneous mixture. Heterogeneous mixtures. Now these mixtures, when we say heterogeneous, it means the word hetero means different. They are mixtures whose components or constituents are not uniform or definite. It therefore means that the components that make up these mixtures can be seen with the two naked eyes, and that is why we call them suspension. What are examples of heterogeneous mixture? Mud water. Mud water is a good example of what? Heterogeneous mixture. Water and oil are heterogeneous mixture. We also have a petrol and oil. Petrol and water is also heterogeneous. What about blood? Blood is a heterogeneous what? Entity or mixture. So these are examples of mixtures. Okay, what about starch solution? Starch solution. So all of these are heterogeneous mixture. Now what does that mean? If I should get some quantity of mud water and put it in a can, I'll leave it for a while, right? If I should leave it for some time, you will observe that at the top of it you have clean water, then at the bottom you have what? Dirty water. That is one of the features of what? Heterogeneous what? Mixture. They can undergo sedimentation. And once they have undergone sedimentation, you can now filter the clean water from it. So all of these are examples of what? Heterogeneous mixture. I believe all that I've said so far was understood. So the next one is we are going to be looking at I'm not going to be wasting my time telling you the properties or the features of the state of matter. Alright, I'm going to be using it, or I'm going to write it on the board, and your assignment is going to be telling me the properties of the state of matter, alright, which are the solid state. These are not new. The liquid stage and the gaseous stage. But let me tell you this: if you are asked by anybody, or when you are asked to give the properties of solid, liquid, and gas in chemistry, there are points that are needed. There are some crucial points that you must state. Now, the three states of matter is divided into three states based on a criterion, and that criterion is what? Their degree of movement. That degree of what? Movement. Matter is divided into three states: solid, liquid, and gaseous state, based on what criterion? Degree of movement. And the degree of movement of these molecules is under the influence of what is called intermolecular force. Intermolecular force. Alright? So if you are stating the properties of solid, liquid, and gas, you must say that the intermolecular force of attraction in solid is greater than liquid, and one found in liquid is greater than what? The gaseous phase. But they'll ask you, in which of these states of matter has its force to be negligible? The three states of matter whose force is negligible is what? The gaseous phase. And that is why they can move zigzagly or haphazardly or irregularly in the container in which they are what? Found. Because the force of attraction found in gaseous molecules is negligible. Okay? And the reason why solid substance is hard is because there's a strong cohesive force of attraction that bind its crystals or molecules together, and that is why it has high density and it has low compressibility. But the gases, they have low density. So the density in gases is not to be compared to solid, but gases, they have high compressibility, but solid has what? Low compressibility. So these are the points that you must state in order for you to have your full mark. So that is how it is. So on the comment section, you are going to tell me 3 properties of the solid, the liquid, and the gaseous phase. Drop it on the comment section and I shall go through it bit by bit. So that is for that. Let us now talk of the structure of the atom. Structure of the atom. Structure of the atom. Structure of the atom. Now, who was the first person to describe the atom? The first person to describe the atom was Democritus. He was known as the first atomist. So Democritus was the first person to describe the atom. He said the atom is the smallest indivisible part of an element that cannot be divided. Do you hear that? He said the atom is the smallest particle of an element or matter that cannot be divided. That was what Democritus stated. But as time went on, a scientist called Sir Ernest Rutherford, said that the atom can actually be split into 3 parts, which we call the subatomic particle. Subatomic particle. He said the atom can be split into 3 parts through the process of what? Nuclear fission, not fusion. Fusion means coming together. That is F-U-I-S-I-O-N. Fusion means coming together. But fission means dividing, okay? So he said that the atom can be split or divided into several parts through nuclear fission. And these parts it is divided into, we call them the subatomic particles. And there are 3 in number. We have the proton, alright, we have the neutron, and we have the electron, okay? Now the proton is what? Positively charged. Alright, the proton is what? Positively charged. And it was discovered by Sir Ernest Rutherford. The proton is what? Positively charged. And it was discovered by Sir Ernest Rutherford. Sir Ernest Rutherford discovered the proton. How was it discovered? He discovered the proton by carrying out 2 experiments. One, we call it alpha scattering experiment or the gold leaf experiment. So the alpha scattering experiment was conducted by Sir Ernest Rutherford. The gold leaf experiment was also conducted by Sir Ernest Rutherford. You should note that the mass of the proton is always equal to the mass of the neutron. The proton and the neutron makes up the mass of a substance or the mass of an element. So the proton number plus the neutron number will have the mass number. Please note that the mass number is also called nucleon. Nucleon, look at the word here. The mass number of an element is also called nucleon. Nucleon, okay? So neutron was discovered by James Chadwick. In the year 1932. Alright, the neutron was discovered by James Chadwick in the year 1932 by bombarding several atoms of beryllium and boron. Alright, so the neutron, which is neutral, yes, it is neutral, that is, it is neither positive nor negative, it is neutral, okay? So it was discovered by James Chadwick in the year 1932 when he bombarded several atoms of beryllium and boron. Take note of that. And the electron was discovered by J. Thomson. Alright, J. Thomson was a scientist that discovered the electron by carrying out an experiment called the cathode ray experiment. So cathode ray experiment was conducted by J.J. Thomson, and it was from this experiment he discovered the electron. And the electron is negatively charged. It is negatively charged, and it determines the chemical properties of an element. These two J's here, this first one is Joseph and this one is John's, that is J-O-N's. Joseph Johns Thomson. Joseph John Thomson, okay? Take note of that. You should know that the mass of the electron is 1 over 1040 of that of what? Proton. The mass of the electron is 1 over 1840 of that of the mass of what? The proton. Please take note of that. You should know that Sir Ernest Rutherford atomic model is called planetary model, okay? Planetary model, right? But J.J. Thomson's atomic model is called the plum pudding model. Why was J.J. Thomson's atomic model called plum pudding? He said that the atom is a spherical shaped object with scattered protons and a bended electron. It said that the atom is a spherical shaped object, that is, it is spherical, not completely circular. It said it is spherical and it has scattered protons and embedded electron. But Sir Ernest Rutherford said that, Thomson, you are very dull. What you have stated is wrong. He says that the electrons and the electrons are not embedded. Rather, they are found revolving round the atom, casting shadows on object placed on its path. He said that the proton and the neutron are concentrated in the nucleus of the atom, meaning that the proton and the neutron are found in the nucleus of the atom, while the electron is found revolving around the atom, casting shadows on any object placed on its path. So in our next class, we are going to be looking at, and please, before I round up the class, let me give you this. Arrow A Millikan, let me drop this. Arrow A Millikan, that is Robert Andrew Millikan. Alright, it was the one that discovered the charge of the electron. Charge of what? The electron through the oil drop experiment. Through the oil drop what? Experiment. Take note of that. Alright. Then another scientist called Henry Moseley. Henry Moseley. Alright, or Henry Moseley. He was the first person to calculate the atomic number of an element. So please, if you have learned something in today's video, endeavor to subscribe, like, share, and comment, so that when I upload new content, you would be notified by YouTube. Do have a wonderful day.